welcome to True Projects. In this video, we are going to explain about the project that is elevating big data privacy and innovative strategies and challenges in data abundance. Before getting into the execution, first let us understand what is the project about. Big data. It is basically the enormous amount of information, that is large amount of data that comes from all kinds of sources, that is from social media, IoT devices, e-commerce platforms and healthcare systems. It is everywhere and is growing fast. This data can reveal tons of useful patterns and trends that help businesses and organizations to make decisions, predict behavior, and also improve services. But here the tricky part is all this data is hard to manage and analyze properly. The real challenge lies in ensuring the data remains secure and private while also figuring out how to handle it efficiently. Although we have technologies such as Hadoop, they help process and manage large data sets. They don't inherently solve privacy concerns, which is crucial issue when dealing with the sensitive information. On top of that, we have techniques that are K-anonymity and homomorphic encryption. So these are the traditional security methods that are designed to protect privacy but come with their own set of problems. These techniques often require significant computational power, which makes them unsuitable for real-time data processing, something that essential when handling with the big data. So, the goal of this project is to develop a hybrid privacy preserving algorithm that strikes a balance between security and also efficiency by focusing on reducing the execution time and processing the data effectively, whether using Hadoop's MapReduce. The aim is to ensure that big data can be securely handled without slowing down the overall system. So, the idea behind the system is to protect the private data while keeping it useful for analysis. So, what do we do here is we break the data into different categories based on how sensitive they are, and they are of key attributes, sensitive attributes, and quasi identifiers. So these are the key attributes. I mean, we will be dividing the data based on these attributes. So here in this project, we have taken the medical data. So key attributes and sensitive include patient ID, patient name, address, and medical history. So these include key attributes and sensitive attributes. These are really sensitive, so we need to take extra care, I mean, extra steps to protect them. So these sensitive points get encrypted using the technique called fine grained encryption perturbation technique, that is FGEPT. So it is called as FGEPT, which is a method to encrypt the data in a way that only authorized users can access it. To make this encryption work, we have used well-known cryptographic algorithms that are RSA and DES. So we have used this RSA and DES algorithms. And we have another category of data, that is quasi identifiers, for example, age and gender, which are not as sensitive but still need protection. For this, we use something called differential privacy. This works by adding a little bit of noise to the data, meaning it is altered in a way that prevents anyone from being able to pinpoint the exact information about an individual. So even if someone tries to access this data, they won't be able to figure out who exactly it belongs to. As we're doing, as we are considering medical data, we are showing the example of these parameters. So these are the examples considered. If you use another data, the key attributes, sensitive attributes, and quasi identifiers will be of different attributes. And to make the system more efficient and handle large data sets faster, here we are using Hadoop MapReduce framework. Essentially, what this does is it split the workload into smaller tasks that can be processed at the same time across different machines or nodes. So in the first phase, it is map phase. So in this phase, the system takes the data set and divides it into smaller chunks, then applies right privacy protection methods to each chunk. This method that this means that instead of processing everything in one go, it does in parallel, which speeds up the whole process. Once once the task is completed, the results are brought together in reduce phase. So this step collects all the encrypted pieces and combines them into a fully secure dataset. The aim here is to make sure that we are still protecting the data properly while also reducing the time it takes to process everything. So by using this approach, we are able to handle big data more efficiently, providing strong privacy protection without sacrificing the performance. This is especially important for big data privacy, where both scalability and speed are the key concerns. So, to make the things more faster and efficient, as an extension, here we are incorporating Chacha 20 algorithm. So, when it is compared to the older encryption methods, we found that Chacha 20 is much lighter in terms of computation, meaning it uses fewer resources and process data quicker. So, we have switched to Chacha 20, allowing us to keep things running smoothly without slowing down the system. And here we took step further by compressing this ChaCha20 algorithm. So we have added a ChaCha20 in compression mode, which means that we compress the data before encrypting it. By reducing the data size, first, we are not only making it easier to handle, but also speeding up the entire process. This method cuts down on the time needed for encryption because smaller data means less work for the system. So, in a nutshell, ChaCha20 and compression together, we are making the system much faster without sacrificing the security. It is all about finding the sweet spot between performance and protection. And to implement this project, we need basic requirements, which are backend languages that are Python, JavaScript, framework of Django, front-end languages of HTML, CSS, JavaScript, and Bootstrap 4, and hardware are processor of 5 and above, RAM of 8 GB and above, and ROM of 20 GB and above, and operating system of Windows. So this is the overview of the project. Now let us execute. So open the code folder, which contains source code files. So these are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? So here in this data set, we have this medical records dataset that we have used in this project for encrypting the data. So let's open it. So this is the data that is being used in this project. So this patient ID, name, medical history, medication, and address are the key attributes that are the sensitive information. Age, gender, and last appointment date. These are the quasi identifiers that are in this project. That is in this data. Let's close this. Let's get back. Here in this privacy folder, inside this folder, there are Python code files that are intended to be dynamically loaded into the project code during runtime. And here in this privacy app folder, inside this folder, there are three subfolders. One is static folder, templates folder, and some Python code files. Coming to static, they have CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And coming to the templates folder, within this folder, we will be finding all the HTML pages used throughout the project. It includes pages like index.html, home.html, and more representing various sections of the website. And we have Python code files that will be executed during the runtime of the application, which supports the project functionality. So this is the SQLite file in which user information will be stored, and this is the manage.py file. This is a command line utility that comes with the Django, and it provides various commands for Django projects, including tasks like running the development server, creating database tables, and applying migrations, and more. And this is the run.bat file. Instead of executing the project through command line interface, we have created this Windows bat file to execute the project. Now we need to double click on it. So double click on this run server.bat file to host the Django framework. So here manage.py file is compiled, and the Django framework will host the application locally at the default address, which is the local host, and the port unless configured differently. So this is the local host, and this is the port generated by the Django framework. So we need to copy this local link provided by Django framework and paste it into any web browser. I'm copying it. I prefer Google Chrome, so I will paste it in that. Paste the link here at the end, type index.html and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Django framework. So here you can see two links, right? That is user login, new user sign up. So first we need to sign up as user, and then only we will be able to log in as user. So let's click on new user sign up and give your all details. So let's add user Kiran and give his password, contact number, email ID, and address. Now click on submit. So here sign up process is completed and we can we can log in to perform all the Hadoop activities. So click on user login here link and give your username and the password. As we have signed up as Kiran, we will log in as Kiran itself. So give the username as Kiran and give his password. So Kiran has logged in successfully. We need to click on load data to Hadoop button so that the dataset file from our local system will be stored in the Hadoop. So click on that. Click on choose file. Open the data set. So this is the data set that we are supposed to upload. So select it, click on open. Here it has been loaded. Now we need to click on submit. So now the data set has been stored from local repository, that is from the local system, to the Hadoop. So here it is stored in the Hadoop memory. So this is the data set that we have stored in the Hadoop. And these are the records of the data set. Let's scroll up. Now we need to encrypt it. So now we will be encrypting without using Hadoop, and we will be encrypting with Hadoop. So first, let's do encryption without Hadoop. So click on that. So this will apply privacy algorithms on the dataset without using Hadoop MapReduce. So here, dataset has been encrypted without using Hadoop MapReduce. So here, dataset has been encrypted. You can observe, right? Patient ID has been encrypted, name has been encrypted, and all the other values are encrypted. All the other features are also encrypted. So for encrypting patient ID, name, medical conditions, and address, we will be using FGEPT algorithm, age and gender. We will be encrypting that using differential privacy algorithm. So here we have encrypted the data without using the Hadoop. Now let's use Hadoop and encrypt the data. So click on privacy with Hadoop. So what will happen now is here we will be applying encryption technique using Hadoop. So the dataset is encrypted using Hadoop MapReduce, and here we can verify the encrypted dataset and see. So this is the Hadoop encrypted dataset. You can observe, right? So these are the encrypted values. Initially, we had numbers in the patient ID column. So here you can see some other encrypted message. So here you can see the values are changed, right? This is the name. You can observe every value has been encrypted. So here you can observe all the values that are encrypted. So now let's apply extension Chacha technique to encrypt the data using Chacha technique with Hadoop. So click on this extension Chacha Hadoop. So here we can observe that Chacha technique has encrypted the data set. You can observe, right? So this is the patient ID. So here you can observe all the records have been encrypted using this Chacha 20. And here name has been encrypted and all the other values are encrypted. So your medical condition is also encrypted. Here, the Chacha 20 algorithm is encrypted with and without the compression mode. We can observe the dataset is encrypted and the execution improvements. So now let's view the comparison graphs. Click on graph to see the comparison. We can view the execution time comparisons between different algorithms and scenarios. So let's come to this scenario where the Chacha 20 algorithm, which is compressed, is compared with the other encryption techniques. And here is a scenario where Chacha 20 is not compressed and compared with the all other encryption techniques. Here on x-axis, we have all the encryption techniques that we have used, and on y-axis, we have execution time. So from all these three parts, we can observe that the data which is encrypted with the FGEPTDS and not using Hadoop is taking the longest time to get encrypted. And the technique by using Chacha 20 with compression and also with the Hadoop, so that data is taking less execution time to get compressed, to get encrypted. And coming to this graph, also the scenario is the same, but here the extension model Chacha 20 is not compressed. Among Chacha 20 which is not compressed and Chacha 20 which is compressed, Chacha 20 which is compressed is taking the least time than the Chacha 20 which is not compressed. So this is all about the project. Now click on log out. In this way, by using the encryption technique that is using with the Hadoop, it takes the less execution time and also the data can be stored securely in the big data ecosystem. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.